Okay, today let's talk about the Codeforces global round. 27, problem D. First part is description. We are given an array B. We can do several operations to these elements, to this array. We can choose two distinct index I and J in this array. That means I is smaller than J. We can change the BI become, if the BI, there is a requirement that means BI is divisible by 2. So we can change BI become BI divided by 2 and make BG multiply 2. This is one operation, and we can do several operations to the B array. Our target is make the sum of the array as possible, as large as possible. Yeah, this is only one part of this problem. Actually, we are given an array A rather than B. For every prefix array of A, we need to return the maximum sum of the prefix array. That means for the A1, we need to return the maximum sum. In addition, for the A1 A2, we need to return A1, A2, A3, we need to return we need to A1, A2, AN. We also need to return the maximum sum. That means we need to return n maximum sums. Okay, this is the description about this problem. Next part, let's talk about solution. In this part, we have a brief concept about this problem. If there are two values, if the second value is larger, if second is larger than the first one, so what we need to do is try to make the last one as smaller and as small as possible, and make the second one as larger as possible, because the second one is very larger. After we make it larger, the sum of the array will be larger as a result. In contrast, if the last one is very small, we don't need change these two elements, because we don't need to make the second one is larger because it is very small currently. This is the basic concept about this problem. Next thing what we need to do is make a clearly strategy when we need to update the second elements. That means for any elements in array, for any two elements in array, we need to check if we should update, if we should make the first one smaller, if we should make the first one smaller and make the second one larger. This is what we need to determine. This is very more important. So this will be the key issue in this problem. In order to solve this problem, we need to change the array A into another way. We can make elements become the base array and the power array. For example, AI equal 20. We can make it base. We can divide this value by 2 as more as possible. The base will become 5 and the power will be 2, because 5 multiplied 2 to power of 2 equal 20. In addition, if the AI equal 8, we can make it base equal 3 and base equal 1 and power equals 3, because 1 multiply to the power of 3 equal 8. This is what we need to do. So after we process the A array, we can get two array base and power. Let's get back to the original question. For the any elements in this array, we need to determine which if we should make the second one larger. Okay, this is tricky question. After we travel the every elements in this array, when we get a new elements, that mean current elements, we have base and power. Let's make the first one. Let's make the two elements, base I and power I. Second one will be base j and power j. So what we need to check is if we should multiply the power I into base g. That means there are two strategies we can use the power I and power g. First is for the power g, the only way is we can multiply into this is the only way we use. We can use the power g into g. We cannot multiply power g into base I. But for the power I, there are two ways to use it. First is multiply it on the base I. Second is multiply it on the base g. So we need to check which is better use method. So for the first one, the value will be if the largest one is larger than if the largest value is larger, the sum of the array will be larger. This is an obvious conclusion because the largest always can provide more value to the answer. So if we multiply the first one, the power I, into base I, the value what we can get is base I multiply 2 to power of power I. In addition, if we multiply power I into base g, what we can get is 2 to power of power I multiply 2 to power of g multiply base g. This is what we can get. So what we need to do is to check which is larger, the first one or the second one. If the first one is larger, that means if the left is larger, actually we can erase the first elements because they are equal. That means the 2 to power of power I. So if the first one is larger, if the left is larger, what we need to do is multiply base. What we need to do is multiply power I into base I. In contrast, if the right is larger, we need to multiply power I into base g. That means if we multiply power I into base g, the second value will be larger. This will make the sum of the array larger, because if the largest largest element in this array is larger, the sum of the array will be larger, because the largest one always contributes more than elements in this array. So this is the main strategy. We need to check where we should multiply the power g into any elements. So for every two elements in this array, we need to check which is larger. First one is base I, second one is base. Okay, this is g. And last one is 2 to power of g and base g. If the first one is larger, we can we don't need we should multiply the power I into the second one. In contrast, if the right is larger, we don't. That means if the okay, let's make it clearer. If the left is larger, we should make the power I multiply base I. In contrast, if the right is larger, we need to multiply all power of 2 into base g, because base g can contribute more value to the sum of the array. This is the strategy. More specifically, we can use the stack to realize this algorithm. More specifically, we have a stack. It is a pair. Stack is a pair. First elements will be the base value. Second is the power. So every time we get a new elements, we need to check the new elements from 0 to n-1, from the first elements to the last elements of array A. We can get a current elements, and we can get a back elements of the stack. We need to check which is larger, which is better, we need to check where we need to add the power of the back of the stack. That means if we should multiply the power of back into current value, we should use this strategy. That means we should use this strategy to have a decision if we should multiply the power of back into current element. If the second one, that means if the current value is larger, we need to add it into it. And that means there are two kinds of results. First one is if the left one, that means back of stack is larger, that means left larger. If the last one is larger, we need to push back. We need to push back current elements. In contrast, if the right is larger, we need to pop back. We need to pop back the last elements in the stack and replace it with current element. Actually, we need to multiply the power of back into current elements. So we need to pop back and update current. We need to pop back and update current elements. The next thing we need to do is compare the back of the stack and the current value again, and do it again. So this is the strategy about the solution to solve this problem. I hope I express it clearly. If you have any confusion about that, welcome to submit a comment below this video. So the next part is complexity. For the time complexity, actually we don't need extra, because actually we don't need some complex algorithm or specific algorithm to solve this problem. The only data structure we use is stack. So the time complexity will be on, and the space complexity is also on. We don't need extra um, space to store the variable. Okay, this is all about this problem. Thanks for your watching.